Hello all and welcome back. In this video, I'm going to tackle an Excel VBA problem that I noticed on LinkedIn. The idea came from a post by Wim, where he asked how to automatically switch numbers into K for thousands, M for millions, while keeping accounting or currency formats intact with symbols like dollar and euro. If you work with accounting and reporting, you know it is very common to show these values as 5.125K or even 0.005125M. Doing this manually is messy, especially when you need to preserve proper formatting, alignment, and negatives. So I built a macro that does all of this for you. Converts number to K or M without breaking cell formatting. Works with dollar and euro in both accounting and currency styles. Handles different negative layouts like these. Stick around and I'll explain the logic and code it live in front of you, and obviously share the demo workbook as well. Before we get into the code, let's take a quick look at the sample data. Here I've got numbers formatted in different ways. Plain numbers, accounting style with dollars and euro signs, currency style with dollar and euro signs, and of course positive and negatives with all their variations. Minuses before the number, after the symbol, or even at the end. This variety is intentional because when you're working in finance or reporting, you'll see all of these in real workbooks. The macro we'll build needs to handle each case without breaking the formatting. Now that we understand the problem, let's head over to the VBA editor and start writing the code from scratch. I'll explain each piece step by step so you can see exactly how it works. To launch the VBA editor, you can go to the Developer tab and click on Visual Basic, or you can also press the shortcut key Alt F11. I've spoken about this in the VBA editor in detail. If you have not seen the video Visual Basic Editor and Introduction, then I highly recommend watching that video. Once you're in, simply insert a module. This gives us a blank space where we can write our macro. In my module, option explicit is inserted by default. I have also spoken about this in the Visual Basic Editor and Introduction video. Option explicit forces us to declare variables, which helps avoid silly bugs. Okay, here is the plan. This shows what we are aiming for. We want to convert numbers into K or M, but without losing the original formatting. That means accounting stays accounting, currency stays currency, and the dollar or the euro symbol doesn't move around. Getting all of that right is what makes this macro a little more advanced than it looks at first. Let's start with the skeleton of our macro. I'll name it Convert Format Up. This is just the outer shell that will hold our logic. Okay, so we need a first line of defense. If you haven't selected a range of cells, there's nothing for this macro to do. So we exit immediately rather than breaking this code. Next, I'm adding an error handler. If anything unexpected goes wrong, we'll jump to the error handler section at the bottom instead of crashing Excel. This section is the error trap. If something goes wrong, we show the error message. Then resume at let's continue, so Excel settings always get reset. We'll be working with settings in a short while. Next, I will declare two variables to store Excel's current state: screen updating and calculation mode. We'll turn them off for speed, then restore them when we are done. I will save the current values into these variables. That way, when the macro finishes, I can restore things exactly as the user had them before. This is important because we do not want to tamper with someone's personal Excel setup. For example, maybe they prefer to keep screen updating off, or maybe they usually work in manual calculation mode. By restoring the settings, the macro cleans up after itself and leaves Excel just the way it found it. So let me quickly write the code. So here I'm capturing the current state of screen updating and calculation, and I'm storing it in these two variables. And then here I'm setting the screen updating to false, enable events to false, and I'm setting the calculation to manual. So this will increase the speed. And here I'm restoring the settings. Now we want to go through each cell that the user has selected and apply our logic one by one. To do that, we'll use a for each loop. And inside the loop, we'll only want to process cells that actually are numeric. So we'll add a check for that. We'll also add a check for dates. We want to avoid that as well. Okay, so let's write the code for that. After the numeric check, the first thing I need is the cell's formatted value. The way Excel shows it, not just a raw number. That's important because I need to detect if the cell already has a K for thousands or an M for millions. Now, if you look at this particular line, I cannot use dot value or dot value to get the formatted text of the cell. Now you may think of using dot text, but that has a big problem. Dot text gives you whatever is currently displayed in the grid. And if the column is too narrow, Excel will show you hash symbols. That's useless for our logic. Instead, I use application.text, which takes the underlying value and applies the cell's number format to it. This way, I always get the proper formatted string regardless of the column width. Now, once I have the formatted value, I check whether it already shows a K for thousands or M for millions. That will tell me what step of the conversion we are on. And once we know that, we need to then decide what to do next. If the cell already has an M, that means it is millions and we don't want to touch it any further. If it doesn't have an M, then it's either a plain number or already in thousands. And in both cases, we still need to convert it. So the next step is to actually perform the conversion. The idea is simple. Take the original value, divide it by 1000 and put the results back into the cell. Also, since the original LinkedIn challenge was only about dollar and euro symbols, I'm going to restrict the code to those two. If you need to handle other currencies, you can adapt the logic accordingly. So let's write that piece of code. So here original value stores the current number. Converted value is that number divided by 1000. And then I override the cell with the converted value. Now that I've converted the number, I need to know what currency symbol the cell had and where it was placed. Was it a prefix like $5, 125 or a suffix like 5, 125 euro? And if it's a prefix, was there a space after the symbol or not? To figure that out, I'll call a helper procedure and I'll pass the cell's formatted text and it'll fill in three variables. The first variable will hold the actual symbol it found, like dollar or euro. The second variable will hold whether that symbol comes before or after the number. And the third one will be a Boolean variable which holds true or false depending on whether there was a space after the symbol. Let's call that helper function getSymbol and position. So this single line delegates all the detection work to a helper. It inspects the string, figures out the symbol and its placement, and gives me back the results. That way, I do not clutter my main loop with parsing logic. The loop just consumes clean values. So let's build the helper that actually figures out the currency symbol and its position. This function will look at the formatted text of the cell and tell us three things. Which symbol is present, whether it was before or after the number, and if there's a space after it. That way, our main loop can stay clean and only worry about the conversion. So let's start writing a helper function. So here's the procedure's signature. I pass in cell text, which is the formatted string we got earlier. The other three parameters are by ref. So this procedure can fill them and pass them back to the caller. Next, we will check for dollar and the euro symbol. If nothing is found, I set the position to none and exit. So let me write that code. So here I initialize currency symbol as blank. Then I check for dollar and the euro symbol. If nothing is found, I set the position to none and exit. Now, if we did find a symbol, I need to figure out whether it comes before or after the number. To do that, I find the position of the symbol in the string and the position of the first digit. So let me write that code. So here I get the index of the symbol and the index of the first digit. If I can't find a digit, I bail out. If you notice, I'm using a helper function to find the index of the digit. I have not written that function yet. I'll do that right now. So whatever string I pass to this function, it'll loop through each character of that string and find out the position of the first digit in that string. That lets our above procedure to decide whether the minus sign comes before the digits, after the symbol, or trailing at the end. Once this is done, we then compare the two positions. If the symbol comes before the digit, it's a prefix. Otherwise, it's a suffix. For prefix, I also check if there is a space immediately after the symbol. Let me write the code for that. So, if the symbol is before the number, I set symbol position to prefix and check if the next character is a space. If the symbol comes after, then it's a suffix and there's no trailing space flag. And that completes our symbol detection helper. Now, I need to know whether the cell is using an accounting format or not. That's important because accounting and currency behave differently. Accounting has special spacing rules. Symbols line up neatly in a column and negatives might be shown in parentheses. Currency is more straightforward. To check this, I'll again have to use a helper function and pass it the cell's number format. And this is how I'll do it. But before that, I'll make sure we only keep dollar or euro symbols as valid symbols. If it's anything else, we'll just blank it out. So this set is accounting to true or false depending on what the helper function finds. So how does this helper function know? Well, Excel uses certain hidden characters in its number format strings when you pick accounting. Things like underscore parenthesis or underscore hyphen or even asterisk. These are padding instructions that tell Excel to leave space for alignment. Those tokens don't appear in normal currency formats. So my helper function will look for them. And if any are present, we call it accounting. So let's write that function. So this simple function checks the format string for those special tokens. If they are there, it returns true, meaning the cell is in accounting format. Otherwise, it's false. This way we can later decide how to build the proper number format when we reapply after conversion. The next thing I need to figure out is how negative numbers are displayed in this cell. In Excel, negatives aren't always the same. Sometimes you see a minus sign in front of the number, like minus 5125. In accounting formats, you might see the minus after the symbol, like shown here. Sometimes the minus even trails at the end, like shown here. And in accounting, you often see parentheses like shown here. If I don't detect and preserve the original style, my macro might change the way negatives look, which is not acceptable for reporting. So I'll call a helper function that inspects the formatted text and tells me what that style is being used. Let's call that helper function detect minus style. So this line calls detect minus style, passing it the formatted text, the detected currency symbol, its position, and the converted value. This helper function will return a keyword like leading after symbol, trailing, or parenthesis. I'll use that later when I rebuild the number format. So the negative style stays exactly the same. Now there are four major ways Excel shows negatives: a minus sign before the number, a minus sign after the symbol, a minus sign trailing at the end, and parenthesis. My function will look at the formatted text and decide which of these styles is in use. So let's write our helper function. So this function takes in the formatted string, the currency symbol and its position, and the numeric value after conversion. It will return the style as a keyword string. Now if the value is positive, we don't need to worry. I'll just default it to leading. But if the text has parenthesis, then it is the parenthesis style. So let's write a code for that. Next, I'll check where the minus sign appears relative to the digits and the currency symbol. So the logic goes like this. If the minus comes after the digits, it is trailing. If the minus is the very first character, it is leading. If the symbol is a prefix and the minus is sitting right after it but before the digits, then it is after symbol. Otherwise, I call it just leading. With this helper function, I can preserve exactly how negatives were displayed before conversion. Also, in this helper, I used two little helper functions: first digit index and last digit index. I've already written the code for first digit index earlier. This is the code. Now I'll write the code for last digit index. This is to figure out if the digit is at the end in the string. Without them, I couldn't tell whether the minus sign was in front, after the symbol, or trailing at the very end. So let me quickly write the helper function for last digit index. So a quick recap, the first one just scans from the left and returns the position of the very first digit. If there are no digits, it gives me 0. And this one works the same way but in reverse, scanning from right to left until it finds the last digit. With both of these helpers, I can pinpoint exactly where the minus sign sits in relation to the digits. So now, together with detect minus style, I've got a reliable way to preserve how negatives were displayed before conversion, whether it's leading, trailing, after the symbol, or parenthesis. That means when I rebuild the number format, I won't accidentally change how negatives look. Now that I've handled the symbol, the format type, and the negative style, the next thing I need to decide is which suffix to show after the conversion. If the number already had a k, then I want to move it up to m. If it didn't have a k, that means it was just a plain number. So I'll add a k. So let me quickly write the code for that. So here what happens is, if has k is true, then net suffix becomes m, otherwise it becomes k. This way the suffix automatically switches from nothing to k or from k to m. And if the cell was already in millions, remember we skipped it earlier. Now that I've got all the pieces, the currency symbol and its position, whether there was a space after it, the correct suffix k or m, the negative style, and whether it was accounting or currency. I can now rebuild the number format string. For that, I'll use another helper function. Let's call that helper function build number format. This function takes all those details and returns a single format string that preserves the look of the original cell while adding the right suffix. So this one line applies the new format to cell. Build number format function will do all the heavy lifting. It will make sure accounting alignment stays intact, the dollar or euro symbol stays in the right place, the negative sign style is preserved, and the suffix gets updated. In short, it will guarantee the converted number looks just like the original, only shifted into K or M. Everything we detected now needs to turn into a single number format string. That format must do four things: keep accounting versus currency behavior, keep the dollar or euro sign in the same place, preserve the negative style, and add the right suffix K or M with sensible decimals. So let me quickly write the helper function build number format. Now the first question is, how many decimals do we need? If the suffix is K, I will allow up to 6 decimals. If it is M, I will allow up to 9. That way conversions are exact both ways. And if there's no suffix at all, I will reuse the cell's original decimal mask. So we do not change how many decimal the users was already showing. Let me quickly write the code for this. Next, I rebuild the currency piece. Sometimes the dollar or euro is a prefix, sometimes a suffix. If it is a prefix, I escape it with a backslash, so Excel always prints it literally. And I only add a space if there was one originally. If it was a suffix, I just attach it after the number. So I will add those changes. Now let's handle the two big cases separately, which are non-accounting and accounting. Non-accounting is easier. We just need a positive format and a negative format. I build the positive once, then adapt the negative version to whatever minus style we detected earlier. Now, for accounting formats, things get more interesting. Excel uses padding characters like underscore and asterisk to align values neatly in a column. That means I need four sections: positive, negative, zero, and text. I'll keep those padding tokens so alignment stays perfect. So let's include that as well in this code. And finally, if there's no suffix, I strip any accidental hash comma hash hash zero decimal fragments from all four sections. That avoids stray dots when numbers don't have decimals. So I will incorporate this as well. So this one helper returns a format string that does everything: accounting versus currency, dollar euro placement, minus style, suffix, decimals, and whether we are going up to K or M or back down to none. It keeps the formatting clean and predictable. Alright, the code is ready. Now let's test it and see if everything works as expected. I've already prepared some sample data in the worksheet. This data is a mix of dollars, euros, positive and negative numbers, even accounting and currency formats. Let's make it easier to demo. I'll add a button on the sheet and hook it up to the macro so we can click and watch it convert. I'm going to name this as up. Now whenever I select a range and click this button, it will promote the numbers plain to K and K to M while keeping the currency, accounting layout and minus style intact. But before I start clicking the button, let me make a copy of the sample data. I'll take everything from column A and I'll paste it into column B. That way, column A stays as my master copy and column B is my testing area. If something goes wrong or if I want to run the macro again, I can always reuse the original data from column A. So let's copy the data. Alright, column B is ready as our testing ground. Let's select the data and click the button to see what happens. Okay, the data got formatted as K. Let's press the button again and it got formatted as M. Awesome, the up conversion works perfectly. The numbers got promoted to K and then to M and all the formatting stayed intact. For reverse, the job is easier. We don't build the format from scratch. So we don't need helpers like currency detection or minus style this time. We just edit the existing format string. So I'll create a couple of small new functions instead. One to check if a number is whole and one to strip the decimal section when it's safe to remove it. Let's go to the VBA editor. I'm going to insert a new module. The reverse has three simple rules. First, demote the value by 1000. Second, edit only the quoted suffix in the format. And third, if K to none and the result is an integer, then drop the decimal section. Let's create a procedure. I'll call it convert format down. Most of the safety wrapper is the same as convert format up macro. Screen updating, calc mode and the selection loop. So let me get that ready quickly. Okay, so the first thing I want to know is, does the format of this cell actually contain a K or an M? Remember, when we added those earlier, they weren't a part of the number itself. They were little quoted text pieces inside the format. So let's pull the format into a variable and then check for those quotes. So here's what this does. First, I store the format in NF. Then I scan it within string to see if it contains M. If yes, that means the format has an M suffix. So has M will be true. Same is with K. Basically, these two lines let me know, is this cell displaying as millions, thousands or just a plain number. So here's the idea. If the cell already has a K or an M, we need to downgrade it. That means two things. First, we take the value and multiply it by 1000. For example, 0.631K becomes 631 and 2.3M becomes 2300K. Next, we don't rebuild the entire format from scratch. Instead, we just tweak the little quoted suffix at the end. If it's M, we change it to K. If it is K, we remove it completely. And finally, if we have removed the K and the number is a whole integer, we also remove the decimal placeholders from the format. That way we don't end up with something ugly like 5125 dot. That is with a dangling dot. Let's type that in. So what this block is doing is, first demoting the number itself by 1000. Then if the suffix was M, it gets swapped to K. If the suffix was K, we delete it and tidy up the format so no extra spaces or stray dots remain. And if the resulting number is an integer, we drop the decimal placeholders to keep it neat. The rest of the format, accounting padding, the dollar or euro, minus style, all of that stays exactly the same. Only the suffix is touched. Now you will notice there are two little helper functions tucked inside here. Is whole number and strip decimal section from each part. Let's create is whole number first. So before we even bother cleaning up the decimal masks, we first need to ask a simple question. Is the number really an integer? That's where is whole number comes in. Floating point numbers in VBA can sometimes have tiny rounding noise. Like 5-digit actually is stored as 5 point so many zeros and then a 1. So this helper doesn't just compare directly, it uses a tiny tolerance in epsilon to decide. If the value is effectively the same as its rounded version, we treat it as whole number. That's the green light to strip off the decimal section from the format string. And there it is whole number is our guard. It prevents decimals from being wiped out unless the value is truly an integer. That way 5125 turns into 5125 cleanly, but 5125.75 still keeps its 0.75 showing. Now let's create the strip decimal section from each part function. Why do we need this? Well, imagine we had 5125K and now we are downgrading it to just 5125. If we leave the old format in place, Excel might try to show it as 5125 dot, which is a random decimal point at the end. Not good. So this helper function looks at each piece of the number format, positive, negative, 0 and text. And if it finds a decimal point that doesn't really need to be there, it chops it out cleanly. That way, whole numbers stay clean and don't carry around an empty dot. Alright, so here's how the little janitor function actually works. Remember, an Excel number format isn't just one piece. It's really 4. Positive numbers, negative numbers, zeros and text. They are separated by semicolons. So what I do here is split the format string into 4 parts. Then send each part off to another helper, strip one section decimal, whose only job is to clean up that one section. Once each piece has been cleaned, I stitch them back together with semicolons and return the result. So really, this function is just the dispatcher. Split, clean, join. So let me quickly write the helper function. And that's it. Strip decimal section from each part doesn't worry about how to remove the decimal. It just makes sure every part of the format gets checked and tidied up. The heavy lifting happens in the helper strip one section decimal. Okay, now let's zoom in on the helper strip one section decimal. Think of this as the actual cleaner that walks into one section and says, do we have a decimal point there? If yes, let's see what comes right after it. If it sees only zeros or hash placeholders after the dot, it keeps walking and scoops them up. Once it reaches something that isn't a placeholder, like a space, symbol, or end of format, it stops. At that point, it removes the decimal point and all those trailing placeholders, leaving the rest of the format untouched. So if the section looked like this, it becomes this, clean and tidy. So let me quickly write the helper function. And with that, our reverse macro is ready. Let's go back to the worksheet. I'm going to add one more button. And I'll tie it with convert format down. Let's call this down. Okay, So we are set. Let's select the data and let's click on down. M converts to K. If we click on the button again, and the data goes back to as shown in column A. So we managed to code the up and the down button as per the LinkedIn challenge. Alright, that's it. We have a complete pair of macros. One to promote the numbers from none to K to M, and the other to promote them back down. And the best part, all the little details are preserved. Currency symbols, whether they sit before or after, accounting versus currency format, minus styles, even parentheses for negatives. Everything stays exactly the way you had it. I've included the link to download the file in the description below, so you can also test it yourself. And if you like this video, feel free to give it a like and share it with someone who likes these kind of Excel challenges. And what's more, if you really want to support this channel, feel free to click on the super thanks button. This encourages me to come out with more content. Also, if you have any questions regarding this video, you can send me an email as usual on support@tamexcel.com. I also have a Facebook group. You can post your question there. The benefit of posting the question in a Facebook is you can include screenshots, you can add more details to the question. There are other experts also who can help you out. And then obviously I'm also on Instagram and also on X. So you can contact me anywhere, any of these platforms. There's also a playlist if you want to learn Visual Basic Programming from scratch using high quality videos which are absolutely free. Then go ahead and check that playlist out. If you like the way I explain things and if you think I can assist you in your quest to learn Visual Basic Programming from scratch, then go ahead and smash that subscribe button. The benefit of subscribing is you'll instantly get an alert when I post my next video. Thanks for watching, and I'll see you in the next one.